Hello everyone, welcome to today's video. In today's video, we are going to talk about the logarithm. And in this section, in this video, we are going to cover all the basics of logarithm. Okay, so to understand logarithm, you must have a prior knowledge of exponentiation and exponent functions. Okay, if you remember, the exponent functions are represented as y equals fx equals ax, or I can write ax equals b, right? And then we have some conditions. First see here, a represents the base, right? And x represent the exponent or index or power, right? And this b represents the real number, right? So this is the definition of the exponent function, provided that there are some conditions on the base, which further says that your base must be greater than 0 and it should not be equal to 1. And we have talked about it in depth in the previous videos. Okay, so this defines, or this sums up your process of exponentiation. Okay, now if I have to relate this process of exponentiation, I would say that the process of inflating balloon is the perfect example of exponentiation, because see here, exponentiation, it refers to the growth. Okay, and when you inflate balloon, then what does it mean? It means the size of balloon grows, so it's representing the growth of the balloon, right? So what I will do here, I will just take one balloon. Okay, for example, this is my balloon. Okay, this is my balloon. Here, this is the original size. Okay, original size means uh, it defines the shape when I bought this balloon from the market, or you can say at that time it was present in its original shape. Okay, or you can call it base. Okay, base. Now base, so here I said at this time, okay, at this time I represent this thing with a knot, right? Why? Because it was present in its base form, right? There is no air inside it, right? So after some time, or as the time passes, I decided to blow some air in it, right? And when I blow the air in it, the size becomes, here, the size becomes this. So I call it, let's say the size is A1. Right? A1, what does it mean? It means that I had blown a units of air in this balloon. So here the size become A1, right? And then same thing happened in next few seconds, and then again I had blown some air in it, again the A units, and then the size gets bigger, it becomes a square, and now this is the shape of your balloon, bigger than this. Okay, so again I repeated the same process, and then again I blow a units of air in, and then the size got a cube, and the shape is something like this. Okay, something like this. Okay, now at this point I stopped. Okay, I stopped and I said fine. So I tied, or I put thread on the balloon at this point, because I said okay fine, now I'm no longer going to put more air in this balloon. So this represents the final size, or here I can say it, this size is B. Okay, B. So if you look at, now see here, if you look at this process of inflating the balloons, it's quite similar to exponentiation, right? Here um, we started with the original size and we got to a cube. Okay, and each step represents the amount of air we put in. Okay, I hope it makes sense. Okay, so uh, here, what was the input? Okay, see here, we got the balloon in its original size, means input, and the air, okay, the air we put in it. Okay, so both these things are going to serve as an input here in this process, and this represents the output. Okay, so I can say here, this represents input and this represents your output. Okay, input means the air that you are blowing inside the balloon. Okay, so here input is going to be the air that you are blowing inside the balloon, and here your output is B, size B. Okay, balloon of size B. So this thing this thing uh, this thing represents the process of exponentiation. Okay, now uh, why I had shown you this thing, because now it's time to to start a logarithm. Okay, and I would start a logarithm by saying that a logarithm is the inverse process of exponentiation. Okay, what does it mean? See here, this process is your exponentiation. Exponentiation. Okay, and now we will see what logarithm means. Okay, so we will see what logarithm means. Now, logarithm, its inverse of exponentiation, means that the output of exponentiation becomes the input of logarithm, and the input of exponentiation becomes the output of logarithm. What does it mean? Here, uh, or here I can say B, uh, or balloon of size B, right? It's going to be input of logarithm, because logarithm is inverse of exponentiation. Okay, and it's going to be input, and here logarithm, and the output is going to be the air air blown. This is your output. So the reverse process, okay, the reverse process is defined as that you have balloon of size b, and you have to find out the amount of air blown inside the balloon, right? So that defines the logarithm. Okay, so here the output is, you can see that the quantity of air blown in the balloon. Understand? And here it was the input. So both the process are inverse of each other, means that the input of exponentiation process becomes the output of logarithmic process, and the input of logarithmic process becomes the output of exponentiation process. Understand? So here, how can we do it? We have to go back in the time, right? Here we have balloon. This is the balloon. This is the balloon of size B, right? This is the balloon of size B. So what we need to do, we have to go back in the time. We have to go back in the time to calculate how much of air is blown inside the balloon. Okay, and here output would be here. This is going to be smaller, and here it will return to the original size. Okay, original size. So it means that here what you did, minus a minus a minus a, and the original size, means you are going back into the time to calculate how much air or how many units of air you had blown, right? So if you see it, it defines the deflation process of balloon. Understand? Okay, so this is the idea of logarithm. Okay, just remember they are inverse of each other. Okay, so the input of this function becomes the output of other function, and the output of first function becomes the input of other function. Okay, I hope this thing is clear. So this was just a rough idea of logarithm. Okay, uh, now we will start the whole logarithm in detail. It was just an idea to give you a sense of idea that it is not a difficult topic. Okay, in fact it is very easy. Okay, so you just have to be visual and listen to the things carefully. Okay, so let's get started. Okay, so I can erase it. Now we are going to start the logarithm. Okay, now see here, this word logarithm, you can break this whole term logarithm, you can break it down into two things, log and a rhythm. Okay, now log means rules, and here a rhythm means arithmetic. Okay, arithmetic, and it specifically means the mathematical calculations. Okay, so here I will write mathematical. calculations. Okay, so the logarithm word is defined as the rules to solve mathematical calculations, or in other words, I can say that it is a tool that simplifies mathematical calculations. Okay, so it simplifies uh, complex mathematical calculations. Understand? So this is the meaning of word or term logarithm. Okay, now see here. Now the next question is that what was the need? Okay, what was the need? I mean, uh, why was it introduced? Okay, so we can say that, okay, if I ask you a simple question, okay, I will say that, okay, just tell me what's the square root of 2, right? So what's the square root of 2? So your answer would be, it's easy, it's going to be 1.414, right? Or if I ask you what's going to be the um, cube root of 27, 27, you would say that, again, it's easy, it's going to be 3. Or if I ask you what's the cube root of 125, you will say that, oh, again, it's very easy, it's going to be 5. Fine, that's okay, because you have learned this. That's why you are not taking time to tell me the answers. But what if I say, tell me the fifth root of 2? Tell me this. Okay, now what would happen? So you would say, I don't know, right? Or if I ask you what's going to be the ninth root of 5? 5, right? So uh, most of them, I don't think that anyone knows the value for this, but most of you will say that, oh, I don't know, but we have to figure it out, right? So that's why logarithm came into the picture to solve these kind of problems. Understand? Okay, so through logarithm, these complex calculations. Now, see here, to find the fifth root of 2, it's going to be a difficult task, okay, if you go through the way of calculating everything, right? But you have to apply some rules that simplifies the whole process, and you can get the answer quickly or values easily. That's why the logarithm came into the picture. Okay, I hope you understand why logarithm came into the picture. Okay, now uh, now let's talk a little bit about logarithm. Let's define it. Let's define it. Okay, I can even erase that. Okay, now let's take any positive real number. Okay, any positive real number. Okay, uh, any positive real number. Okay, so any positive real number, okay, it can be represented in two ways. Okay, if you look at any positive real number, there are two ways to represent. Okay, so this is going to be the first way, and here we are going to represent it second way. Okay, so the first way to represent any positive number is our our exponential representation and the other way to represent the same positive real number, it is logarithmic representation. Okay, so exponential representation, it's of the form ax equals to b. Okay, and the logarithmic representation, it is of the form it is of the form log b to the base a is going to be x. Log b to the base a equals x. Now see here, let's define the components here. Okay, here in exponent functions we call it base, and this is our, what is b? This is going to be the real number, right? And what is this x? X represents exponent, okay, or index or power, right? So here this is going to be real number. Okay, we'll define it later there. Okay, and here in logarithmic representation, this is going to be your argument, right? Because you are calculating the log of this number, right? And then this represents the exponent, this represents the base. Okay, so both are inverse of each other. Here we have a condition, that a, the condition is a must be greater than 0 and a should not be 1. Here we have the same condition, a must be greater than 0 and a should not be 1 and b greater than 0. Okay, so both are inverse of each other. Now we said that any positive real number can be represented as this, okay, in two ways. So we can take any number. For example, here we can take number 25. Okay, now 25 can be represented as, 5 square equals 25, right? And on the other side, in this way, it can be represented as log of 25, log 25 to the base 5 is 2. Okay, so if you look here, what log means? Log means the power to which the base should be raised to get b as your answer, right? That means the logarithm, right? So here it says the square of 5 is 25, and here it means that to what power this 5 should be raised so that your answer is 25. So if you raise 5 to the power 2, only then you get 25. Therefore, log 25 to the base 5 is 2. Okay, I hope you Get the point, right? Let's take one more example. 49. Okay, now this 49, it can be represented here as 7 square equals 49, right? And the logarithmic representation would be log of 49 to the base 7. Now, what does it mean? It means to what exponent or power this 7 be raised so that your answer is 49. So you have to raise base 7 to the power 2, right? So here the answer is 2. Okay, you can take any other example. For example, 27. Okay, so 27 can be represented as 3 cube, right? And the logarithmic representation would be log 27 to base 3 would be 3. Means that to what exponent this 3 be raised so that your answer is 27. So, of course, you have to raise 3 to 3 to get 27 as your answer. Okay, so logarithm, it means it is the inverse of this. Okay, so here I'm going to write one thing, and you can just note it down. Okay, you can just note it down. Okay, so if I have to define logarithm, it is if your a sorry if ax equals b, then log of b to the base a equals x. This is, it implies and implied upon. It implies and implied upon means this equation works both way. Okay, this statement works both way. It implies and implied upon. Okay, so here your base for both, your base must be, it must be positive, it should not be 1, and b should be greater than 0. Okay, log of negative numbers is not defined. We are going to talk about it in detail later. Okay, and I will show you why it is not defined for the negative numbers. Okay, so this represents the concept of logarithm. Okay, so if you have to define logarithm, you have to say that logarithm of a number, logarithm of a positive. Okay, we can write it down here. A logarithm, THM, logarithm of any positive real number b is defined as the exponent to which base a must be raised, is defined as the exponent to which base a must be raised to get to get logarithm of any positive real number b is defined as the exponent to which base a must be raised. Okay, this is the definition of logarithm. Okay, so you if someone asks you what is logarithm, okay, so logarithm of any positive real number is the exponent. Okay, so now see here, when we are finding the logarithm of any number, actually what are we finding? We are finding the power. Okay, so it is defined as the exponent of or power to which base must be raised so that you get the same number as your final number, right? Okay, so that defines the logarithm. Okay, now let's see some questions on it. Let's see some questions on it. I've got some questions for you. I hope this is clear, right? It's very simple. Now, see here. In some books, maybe they have represented your exponent function as ax equals n. So the logarithmic function would be log n to the base a is equal to x. Because we are using b here, because in my previous videos when we define exponent functions, we have used ax equals b. So just to let things, you know, float easy, so I'm just using the same representation. Okay, in some books they are using different notations, but meaning is the same. Okay, now let's do some questions on it. Okay, now see here. So we know that if this is your exponent function, then how to write the logarithmic function. And I'm going to talk about these three conditions in detail in few minutes. Okay, but let's do some questions first. All right, so our first question is what is log 125 to the base 5? Okay, this is our first question. Okay, now this question is very easy, because if you look at it, okay, if you look at it, you can see this is, okay, on okay, here by definition, by definition log of b to the base a is equal to x, right? So if log of b to the base a is x, what does it mean? It means a x is b, right? Yes or no? So here it's very easy, because if you look at it, you know that, what does it mean? It means that to what exponent this 5 should be raised to get 125 as your answer. So means that to what power this 5 should be raised to get 125 as your answer. Okay, so it's very simple. So if this is your x, so it is going to be 3, right? I hope you understand. Okay, so your answer is going to be 3. Okay, now let's go to the next one. Log of uh, log 2, sorry, log base 2, your x square equals 6. Okay, now This is the given question. It says that log of x squared to the base 2 is 6. Then you have to find x. Okay, now see here. If you compare it with the definition, what the definition says, by definition, log of b to the base a is x, right? So log b to the base a equals to x. It means that ax is going to be b, right? So what does it mean? It means that to what power? What does it mean? It means that to what power this 2 must be raised to get x square as your answer. But here the power is given. So 2 raised to the exponent 6 equals x square, right? And this is 2 times 2 times 2 times 2 times 2. It is 32. 32 equals x square, right? No, not 32. I think 64. 64. So if your x square is 64, it means x equals plus minus 8. I hope this thing is clear to you. Easy questions, right? Then, okay, come to this side. Question number 3. Question number 3 says that log of this equals what? Okay, now see here. It says that log of this to the base 2 equals what? Okay, and here again you are given the number in the form of logarithm, right? So now here what we can do is this whole thing. Now the problem is this thing, right? Because if this thing is a positive real number, then things will get sorted out very quickly. Okay, so we have to do something about these things. Okay, so we can say that this thing is b, right? Because log of b to the base a. So let's say uh, log 9 to the base 3 is n, right? It is n. So what does it mean? It means that we have to find this, right? We have to find n. So it means that to what value this 3 must be raised to get 9 as your answer. Okay, so to what value, to what exponent this 3 must be raised to get 9 as your answer. So it's going to be 2, right? It's going to be 2. So n is going to be 2. So this whole thing will be changed to log of 2 to the base 2 equals what? Now, what does it mean? It means to what exponent this base 2 must be raised to get 2 as your answer. So it should be 1, right? So that's why, therefore log 9 equal to 2, equal to 1, equal to 1. So 1 is the correct answer. Easy questions, right? Then number 4. Question number 4 says, if log of log x to the base 3 to the base 2 equals to find x. Okay, let's see this problem. It says that if log of log x to the base 3 to the base 2 equals to, then we have to find this x, right? So what we can do here, let's do something about this, right? Do something about this. So if this is 2, okay, so this whole thing means that this whole thing means that if you raise this base to the exponent 2, you must get this as your answer, right? So it means 2 raised to the exponent 2 should be equal to this number, right? So log of x to the base 3. Now, things are easy. So I can say 4 equals log x to the base 3, right? Now, you have to find x. So what does it mean? It means that you have to find this number, and this number would be equal. What does it mean? It means that you have to raise this base 3 to the exponent 4 to get x as your answer. So which represents 3, this is base to the exponent 4 equals x. So if you solve it, your x is going to be 81, right? Easy question, okay? The complex part was to get this, right? But it's very easy. Just you are given with the logarithmic form, you have to make use of the exponential form, right? So I have just converted this logarithmic expression into the exponential expression. And then what has happened here, again I got another logarithmic expression, and again I changed this logarithmic expression into the exponential expression, right? And then I got the value of x. Easy, right? Let's do some more equation. Equation number 5, which says that if log of x minus 1 to the base 2 is defined, then find the smallest possible value, find the smallest possible value of x. All right, so let's see. Now it is given to you that this logarithmic function is defined, right? So this is defined means it is a logarithmic function. So if it is defined, then you need to find the smallest possible value of x. Now see here what we will do about it. So this log of x minus 1 to the base n is defined. It means it is a logarithmic function. Okay, now if it is a logarithmic function, then by definition, see here, because log of b to the base a equals x, provided that this b must be a positive real number, right? So this must be the positive real number, means that x minus 1, it should be greater than 0, right? What does it mean? It means that x must be greater than 1, right? So x must be greater than 1. It means that 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 the value of x is going to be 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 any value between 2 and positive infinity. Okay, so but the question says that the smallest possible value of x, so the smallest possible value would be 2. Therefore smallest possible value is 2. I hope this is clear to you. Okay, let's take few more questions. All right. Yeah. Okay, so there is one more question, number 6. It says that if log x minus 1 to the base 10 minus x is defined, then 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 find the possible integral values of x. Okay, now see here, we have to find the values of x. This statement is very important. If this is defined, means then it means it is a logarithmic function. Okay, now by definition, you can see, where is the red? By definition, this is solution. By definition, log of b to the base a equals x, provided that your b greater than 0, your a must be greater than 0, and it should not be equal to 1, right? So if it is a logarithmic function, it has to follow this condition. So b must be greater than 0. So first condition is that x minus 1 must be greater than 0. And then this a greater than 0 means second condition. This is first. Second is 10 minus x is greater than 0, second. And then third is 10 minus x should not be equal to 1. Right? So from here we can say that x must be greater than 1. Okay? And from here I can say that x must be less than 10, right? Yes or no? Yeah. From here, x must be less than 10. And from here, x should not be equal to 9. Okay? So, x greater than 1, less than 10, but it should not be 9. So, x is going to be 2, 3, 4, 5, 6, 7, 8. Yes. How many values? 1, 2, 3, 4, 5, 6, 7. Okay, so this is going to be your answer. Okay, so very simple. These all defines the basic problems. Okay, now quickly we can do some basic properties. Some basic properties of logarithm. So just let me erase it. Okay, write down some basic properties. Okay, some basic properties. Property number one is log of b to the base b is 1, right? Where b is greater than 0 and b is not 1. Okay, just write it down. Then second is log of b to the base 1 by b equals -1, b greater than 0, b is not equal to 1. Okay, then third property is log of b, uh, log of b log of 1 to the base b is 0, where b is greater than 0 and b is not equal to 1. These are the basic properties. Understand? Now, see here, you can, first property, you can take any example, log of 5 to the base 5. Now, see here, what power should I raise this base 5 to get 5 as my answer? So 1, right? Or log 3 to the base 3. So what exponent should I raise this 3 to get 3 as my answer? 1, right? So this holds true. Okay, come to this log of 9 to the base 1 by 9. Now, what power should I raise this base to get 9 as my answer? Now see here, 1 by 9, what power should I raise it to get 9 as my answer? So it should be -1. So see here, true. Okay, or log of 1 by 3 to the base 3 equals what? Now, what power should I raise this 3 to get 1 by 3 as my answer? -1. So this is going to be -1. Okay, I hope this is clear. And here, any example, log of log of 1 to the base 5. Now, what exponent or what power should you raise this base 5 to get 1 as your answer? So means this, right? So what's going to be the value of this? X is going to be 0. Okay, so these are very basic properties. You must learn these properties. Okay, so that's all, but we can do some questions on these properties. So please write some questions. Write some questions. Okay, first question is log sine 30 here cos 60 degree. Okay, second is log log 5 10 45 degree. Number 3 is log of secant square x minus tan square x to the base 2. Number 4, log 0.1258. Number 5, log 2 plus root 3 to the base 2 minus root 3. Okay, so let's start with number 1. Now see here, it can be simplified as log cos 60 is 1 by 2, and sine 30 is going to be 1 by 2, right? So this is a log of b to the base b, right? This property number 1, so it's going to be 1, right? Next, log of 1045 to the base 5. Now, what is 1045? 1045 is 1, okay? And log of 1 to the base 5, log of 1 to the base p means that to what power should you raise this 5 to get 1 as your answer? So the answer is 0, right? Come to this one. This is the main property in trigonometry, uh, basic properties, I would say, when we study these trigonometric functions. Cos square, no, sorry, secant square theta minus tan square theta equals 1, right? So cosecant square theta minus cot square theta is also equals 1. So this whole thing is 1, and it says that log of 1 to the base 2. So log of 1 to the base b, it should be 0. Okay. This is, if you look at it carefully, the base is 1 by 8. So log of b to the base 1 by b, it's going to be minus 1, minus 1. Now, next is 2 plus root 3, 2 minus root 3. They are the conjugate pairs. Conjugate pairs means that when you multiply these two numbers, the product is going to be 1. So it's going to be log of, they are reciprocal of each other. So I can write this as 2 plus root 3 here, and here 1 by 2 plus root 3. So it's going to be here minus 1, right? Or see here, if you do not understand it, so what I did, 2 minus root 3, right? So if you multiply and divide with 2 by root 3, 2 plus root 3. So what would happen here? It will be 4 minus 3, and here 2 by root 3. 1 by 2 plus root 3. See. So I hope this made sense, okay? So that's all about the basics. In our next session, we are just going to see these basic conditions that we have on logarithmic function, why the base must be greater than 0, why the base must not be equal to 1, um, and yeah, these two conditions. Okay, so I will see you in the next video. Till then, stay safe and take care. Bye bye. Thank you.